top and putting in more fuel,
yeah.
and it was kept
Fine.
running.
Just keeps running.
Yeah.
Yeah. So you have a little window of space that you can add fuel that'll keep running because it's really creating a vacuum. It's going to burn here. It's going to get the air here anyway, right? So it's now drawing air through the top of that. But what's bad about drawing air into here is that it now becomes a combustible area, right? You're making mixtures of air and whatnot. So if that heats up, you can produce gas in there, and then you can get an explosion, right, in your barrel.
Yeah.
So you don't want air in there, but while we're changing the fuel, we can get air into there. So all that systems, now we switch to the waste system. So this is a shaker that's shaking the inside of the grate. The traditional import design had a rod that you shook or you moved around. They had to do that all the time. You see the old videos, the guy gets off the bus, he runs over the bus, he shakes the hell out of the grate, and the engine goes, starts up again, and he jumps back in the bus and they drive off. That's the way the inverts used to work, right? The guy would always have to go out there and do some shaking or manipulating of bridges and things like that, right? So that's our automated solution. It shakes.
So did you make that, design the shaker, or is it just Bear
and I helped design the shaker and got together and did a lot of design on that, yeah. And along with this barrel, I did most design on the barrel, but that was like a conversation between me and Jim. Everything's a collaboration here, you know? Yeah. So yeah, we get the ash out, so you can take out ash. Right now, we've been running it for, this is about 17 hours worth of ash.
Hardly any.
Right.
And I'm surprised just at how much it's charred.
Yeah.
Now this is moist too.
I had to put water on it when I took it out.
Oh, right. Yeah.
Which I found out is if you take a hot ash out and put it in water, you're breaking a patent by some biochar bag. Patent that. I was like, what? It's like what everybody has to do. So anyway, the ash comes out there, and you can open this up during operation. It's been open. I've left it open just to see what would happen. I close it. It's a valve like anything else, right? And I probably left the auger on for a long time. It's fine. So I'm gonna let that cool down, and I can open that later and see how much ash we had in the last 3 hours, which is what I was interested in.
Yeah.
Right? So we also have power monitoring here. This is our power block. So the power is coming off the Alpha 4-pole generator right now, right? Producing 60 hertz power, 120 volt AC, right? So that's coming to this power block here, which is basically running the 3,000 kV that I think that we're running. I'm pretty sure we're running. I don't know what. I think looks like we might have burned out a light, but we have like 3 kV of cheap Chinese lights on, right? Which is good enough. So we're running at 3 kV because that's like just a good testing. We're not using tons of fuel. We can run it at 10 kV, but it's really about fuel usage for us. We don't have that much fuel here, so we want to keep it easy on us. We're not going to be throwing tons of fuel on there. We don't have 10 kV lights. It's just a waste for us. So it's better just to run at 3 kV, knowing that we can do that. Just keep it nice and easy and just have everything work and braking in the engine. You know, we don't want to run at super high RPMs right now.
Now this is your smaller engine. Also, you have this bigger unit over here that we've been working on this weekend.
Yeah, so we have
Is it basically the same size parts and everything? Just the engine's different?
Everything's sized a little bit bigger. The hose that you can see is bigger. The hopper's going to be bigger. That's going to be sucking down wood chips, right? And the bell on there the throat is open because everything's a size bigger. It's classic engineering, you know. The curve, everything goes up, you know. So, but most of the parts are the same, you know. There's similarities now, so that's why we started small to go big.
Exactly.
So we've got this kind of figuring out. Now we can ramp it up a little bit.
All right.
And so all this again is being data collected. So all the data is being collected on the screen here. So this is our data streaming, right? So we have the energy that we're producing and how much watts we're using. I think the watts is here is 3,383. So we have all this like information here that we're getting. Temperature of the reactors, you know, what's on and off, when it turns on and off, how hot it is it hot, is there an alarm on, do we have problems, you know, this is all data logged for us so that we can see what's going on, right? And so that's one feature. This is the other feature here. This is our gas analyzer, which I don't trust it right now. I think we have an air leak in our hose, a little small micro one somewhere. And I've been trying to hunt that down, but it's pretty accurate. So we have 1,200 kilocalories per meter cubed of gas. So that's our gas quality right there. That's good. That's good gas quality. And then we have our ratios of CO, CH4, H2, CO2. You know, the O2. You can look at them all. So this is a gas port analyzer that we use, and it's just a small little pump, and it just pumps the gas into it, and we can measure what we got.
All right. Cool. And so that's that little plastic tube that here has the water.
This is the one with the water in it. It's the gas coming in. So that's why I think I'm getting weird readings every once in a while. I think it gets blocked or it's not set up right. Or there's a splice here that's not perfect, but it just ports out of here. You know, goes back into the back. There's the weight must.
All right.
And then, you know, load bank. So it's loaded. You can see the lights are on. Lights are on.
And so you got an order for 10 more of these? Something?
Yeah. Can't wait.
All right. Well, thank